Hi class, I want to go over a problem that seemed to be missed by a lot of you on exam 3, and this will be on exam 4 and the 5th exam as well, and then on that optional final. So let's take a look at it. We're going to analyze a rational function. A rational function just simply being a quotient of two polynomials. So this problem had you first start with finding a domain, x and y intercepts, and then investigating asymptotes, both vertical, horizontal, and oblique. So I think the first thing we want to take a look at here is where this value, or where the domain values are for this function. So many of you got this correct. You knew that down here in the denominator, x minus 5 can't be 0. So by knowing that x minus 5 can't be 0, we know that x cannot be 5, right? So you were able to come up with that concept. However, when we went into the x-intercepts and y-intercepts, many of you during your analysis claimed that x equals 5 is a location of an x-intercept, which it can't be if it's not in the domain, right? So how are we going to find x-intercepts? Well, we're going to start by taking where our function value is 0. So we'll set that numerator equal to 0. 0 is equal to 2x squared minus 9x minus 5. And with a little bit of factoring and solving for this using the 0 property, we'd see that we have 2x plus 1 and x minus 5 is equal to 0. And this is where many of you came up with that solution of x is equal to 5 is an x-intercept. It does in fact make this 0, but since it's not in the domain of the function, it can't actually be an x-intercept. So there's only one, and that happens where 2x plus 1 equals 0, or when x is equal to negative 1/2. Now, this is not obviously the same problem that all of you had. It's different for each of you, but this is the basic concept. So now when we are looking at y-intercept, most of you had no trouble with that. Finding the y-intercept, we're going to just set x equal to 0, which means our y would be equal to 0 minus 5 over 0 minus 5, or we see that's just positive 1 for that guy. Okay. So that's the location of it. The actual intercept itself is 0, 1, and over here the actual point for this guy is negative 1/2, 0. And then lastly was the asymptotes. This is where most of you made some mistakes, looking for vertical, horizontal, and oblique. I think most of you did pretty good with horizontal, knowing just the growth of a quadratic function versus a linear function. We know that this is going to grow faster than this guy, leading us to have no horizontal asymptote. When we head off to infinity in either direction, that function value will increase. So that was okay. No horizontal asymptote. I think most of you got that. The vertical asymptote, many of you looked and said, well, if x can't be equal to 5, then 5 must be the location of a vertical asymptote. Sometimes that's the case, but it's not always the case. So x is equal to 5 gives us a location of a possible asymptote, but I think we can look at both the vertical and the oblique here by analyzing this function a little bit more. So by factoring the numerator here, as we had done in part B, we see that this function looks like 2x plus 1 over x minus 5 divided by x minus 5, which we often will write this as this is equal to 2x plus 1, specifically when x is not equal to 5. Which means that for every value in the real number system other than 5, this rational function will behave exactly like this linear function. The only place they don't agree is at 5. This function's undefined at 5. This function's very well defined at 5. That's why they disagree. So, if it's going to behave just like this, 2x plus 1, everywhere, except for this one point, the infinitely many points in the real number system, it's going to be linear, except for this one point. That's what leads us to this guy just being simply a hole in the function, and specifically a hole in the linear function. So not an asymptote at all, just a hole in the function. So when we look at undefined points in certainly a rational function like this, we need to be able to analyze whether that in fact does lead to a vertical asymptote or whether it just leads to a hole in the function. And a good rule of thumb is if that value that you've excluded from the domain makes both the numerator and the denominator 0, then it's what we call a removable discontinuity, and we can take that out and redefine the function as some simpler function with the specification that it can't be that one domain value. That should say when x is not equal to 5. Okay, so in this case, we know that there is no vertical asymptote based on that. No vertical asymptote. And then how about the oblique? Many of you said that there was an oblique asymptote, and it was in fact 2x, y is equal to 2x plus 1. The reason that's not the case is because this function is in fact linear everywhere except for that one hole. So there's no asymptote, there's no value that we approach. We are in fact on that value the whole time. So there would be no oblique as well. So kind of an interesting problem to analyze a rational function. In fact, we have no asymptotes with this function at all. It simply looks like a linear function with a slope of 2 and a y-intercept of 1. So it's going to cross right here. It's going to have a slope of 2, and then at x is equal to 5, say out here somewhere, we have a hole. So this function will look just like this. Nothing more than a linear function with a hole. Thanks, and I'll post another video on another problem from exam 3 shortly.